Okay folks, so we're going to move on to the next handout now, and it's the project setup handout. It's a single page file there, so project setup, this is the one that you're looking for. And so to discuss this, I'm just going to close the file I've got here, and I'm going to go right back down to the Revit desktop. And I'm going to open up a new file with the architectural template. So Control N. Yeah, you can close all the files and not save them. So close all the files, go back down to the Revit desktop, and then open up a new blank project using the architectural template. Now in this file, I want you folks to go to the south elevation. So in the south elevation of your project, when you zoom in on the first two levels of your project, I'm sure that in most of the offices where you folks work, when you are working on a commercial project, you don't set your main floor to 0. Typically, you will set your main floor to 100 feet if it's an imperial project, or 100 meters if it's a metric project. Now, of course, the reason that you do that is that if you have any levels below the main floor, you don't want them to be negative numbers. So for instance, if I zoom out here and just add a new subgrade level, so here's my first parkade level and my second parkade level. I'm not worried about their exact heights here. So if I go in and rename these to parking P1 and parking P2, you folks can see I have negative numbers. That is very confusing for your contractor to deal with, and it's just confusing in general. So we don't want to have negative numbers for our level heights. So what we do to facilitate this, if you look at the instructions here about how to set up your project, what we're going to do here is, in your project, go to your visibility settings, VV, go down to the site category, and turn on the project base point. So you're going to see the circular icon there, which is your project base point. Now, as I mentioned earlier, you can unclip the project base point and move it. Now, if you're exporting to AutoCAD from Revit, this will be 0, 0 in your AutoCAD drawing. So wherever this is in your plans, that will be 0, 0 in AutoCAD when you export to AutoCAD from Revit. Now what we can do is, if we unclip it, we can now move the project base point, which not only will change 0, 0 when you export to AutoCAD, and that's perhaps not really that important right now, but I just want to let you know that that is what will happen. But if we unclip it after we've selected it, and we use the move command, so select your project base point, grab the move command, and then drag it straight down on your screen, and type in 100 feet. This will set your main floor to 100 feet. So your levels are paying attention to the location of the project base point and reporting their elevation with respect to the vertical location of this icon. Now, why did we have to unclip it? Well, let's say that it wasn't clipped and you tried to move it down 100 feet. It won't move. Now, there's some notes about what's actually happened there. If you move the unclipped project base point, it actually ends up moving the survey point in the opposite direction by the same amount. Go back and look in your notes and you can check that out. So we have to unclip it to move it down 100 feet. And by doing so now, our main floor is at 100. Now, if it was a metric project, you'd move it down 100 meters. So that's noted in your handout there. So a good thing to do when you set up your project. Okay, so we are going to move on to the third handout here. And you can feel it's pretty thick. Advanced site modeling. Now, one of the best things that I really like about Revit is the ease with which we can model the topography of our sites. So here in BC, we often have sloping or undulating sites that we have to work with, and it's nice to be able to respond. It's nice to be able to respond to the needs of the site when we are designing our buildings. So that's why Revit brought in this module to allow us to import site geometry on the Massing and Site tab. So hopefully in the intro course and in your own experience, you've had an opportunity to use the Toposurface tool. So there's a variety of different ways that you can build the topographic model for your site. So a look at the top of the notes there, you've got the two different methods there. Using CAD data, so that's a survey file from your surveyor. And you can also bring in, if someone provides it to you, basically an Excel file with X, Y, Z points in it from surveying equipment. But typically, you're going to bring in CAD data from your surveyor. So the process for doing this is right there under the next heading halfway down the page, using the Toposurface tool on the Massing and Site tab. So let's give this a go, if you folks haven't had a chance to do so already here. So go to the Session 1 folder on the Share Out drive, copy that whole folder, paste it to your desktop. You don't have this handout? Okay, all right. Anybody else missing notes for tonight? Just you? You're the only one? Oh, you've got it now? Okay, all right. Okay, so grab the entire Session 1 folder from the J drive and copy it to your desktop. And so what we're going to do now, if you folks go back to your site plan in this file that you're working on right now, what we're going to do is import a CAD file so we can build this topography together. So before we build the Toposurface, we need the CAD data from the survey. So go to the Insert tab next and choose Insert or Import CAD. So Insert tab, Import CAD. And then what you need to do is go to the Session 1 folder on your desktop. And we're going to import the site plan AutoCAD drawing. Now, there's a few settings I want to go over here. before we get started. So when you bring your site plan in from your surveyor, here in Canada, in most instances, it will be in meters. And the units will probably, and I say probably, be set in the AutoCAD drawing from your surveyor such that if you use auto detect as your option in the import dialog box, you should be okay. Now, one thing that you absolutely want to make sure that you do is uncheck this box at the bottom. Correct lines that are slightly off axis. Now, why is this? Well, as you folks may know, a lot of property lines are really close to being perfectly straight up, like straight north. You know what I'm saying? Like 0 degrees, 0 minutes, 5 seconds. Or 0 degrees, 1 minute, 30 seconds. Like really close to being straight north on your screen, but not quite. So if this box is checked, Revit will see those property lines that are almost pointing straight north and very helpfully make them point straight north, which of course is not what you want. So that can drive you crazy. So make sure that that is unchecked when you are bringing in that CAD file. Now, leave your units as auto detect for the time being, and then if something seems like it's really wrong, we can come back and choose meters manually, or whatever unit you think it might be. So I'm just going to leave it as auto detect and hit open. That's looking pretty good, scale-wise. I'm pretty sure this thing was done in feet, because it's an American survey. And American surveys will be done in decimal feet. Canadian surveys will be done in meters. Now, if you folks go to the 3D view, of course you can see that the topographic lines that have Z coordinates, so we can clearly see that there are Z coordinates in this AutoCAD drawing. Now, when we use the Toposurface tool, sometimes we don't know which layers have the topographic information on them, right? So once you've got the CAD file inserted, we can go back to the Massing and Site tab, and now we can use the Toposurface command. Now, when the Toposurface command fires up, to make use of this AutoCAD drawing that you have imported, you can use Create from Import and select Import Instance. Now, my mother was an English teacher, and when I look at this, I kind of cringe inside because it looks like English, but I really don't know what the hell it's saying. Create, import, select import instance. Pick CAD file. Like when you said pick the CAD file, so nice. Pick the CAD file from the Create from Import menu, and then you put your cursor on top of the CAD file, and you will see a blue box. So now when you click the AutoCAD drawing with the blue box around it, you'll get this. Okay, that's on the Massing and Site tab, Toposurface command. Now, sometimes you will open an AutoCAD drawing and there will be like a bazillion layers in there and you're not sure which one they are. Which ones have the topographic information. So, I'm just going to hit cancel here. And I'm going to bail on the Toposurface command. You folks don't have to, because I'm just going to point this out. Prior to using the Toposurface command, there's a little tool that's built into Revit that will help you identify what layers in your survey actually have topographic information on them. And it's mentioned elsewhere in the notes. I might not be in exactly the right place for that, but I'm just mentioning it now. So it'll be on YouTube for you folks. prior to using the Toposurface tool, if you click on the surveyor's CAD file, and this applies to any CAD file that you've inserted, if you click on the surveyor's CAD file, you can see it's all turned blue on the screen. Up on the ribbon, you folks will notice that there is a query command. And with the query command, you can only get access to it if the CAD file is selected. So you can see CAD file not selected, no query tool. CAD file selected. Now I have a query tool. So with the query tool, you bring your cursor down and you put it over some of the geometry from your CAD file, and you can see it's going to highlight that geometry. So I've got some contour lines here. So if I put my cursor over one of these contour lines and click it with the query tool, it pops up a dialog box. And it tells you what layer it is. C, Topo, Minor. Okay, cool. How about this yellow one here? C, Topo, Major. Great. So in 3D, if you're not sure, you can go to your 3D view and you can look for lines that have 3D information. Sometimes things like your property line will be floating way down below the contours, because typically your survey CAD file, all of the property lines and the building outlines will be at Z equals 0. And then your contours will be at their actual elevation floating above the ground. So in 3D, you can click on your AutoCAD drawing, use the query tool, and you can see which contours are actually floating, pick them, and keep a note of what their layers are. Now once you're satisfied that you've found all the layers, you can just write them down on a piece of paper or just remember them. Then you can go back to the Massing and Site tab and now pick the Toposurface tool to start the process of creating the Toposurface. So here we go again. Create from import. Select import instance, and once you've clicked on select import instance, you got to pass your cursor on top of the CAD file and you'll get a blue box around it and click it. Then it's going to pop up all the layers of the CAD file, and typically there's only 2 or 3 layers from that CAD file that you're interested in. So I'll pick check none to begin with. So all the layers are deselected. And I'll pick the major and minor contour layers, and that's it. That's all I need to build the contour model. So if I hit OK, there's the contour data coming from the polylines in the surveyor's CAD file. So each of those black dots, if you're wondering why in the world those black dots are there and how they arrived and where Revit gets off on making that many dots, those are the vertices of the polylines created by the surveyor. So when you're looking at all these dots, if you guys know how surveys are done, typically a surveyor has an instrument called a total station. It sits on a tripod. It's got a little device on top that's got a laser that shoots out, and there's a guy who holds a stick with a prism on the end. And so the rod man, as he's called, he'll wander around and he'll go to like 200 different locations on the side of the hill there, and they'll turn the laser and shoot it at that prism, several hundred times, come back to the office, and the surveyor's software will interpolate between those several hundred points and build all of these contour lines that you get in the survey from your surveyor. Well, look at all the points here. There's like a bazillion points there. Did the surveyor shoot those bazillion points? No. A lot of these points are just interpolated. So it's frankly, it's topographical bullshit. It's not. If you went to the site, it's probably a little bit different than what you see here. So what you've got to do is decide if you need this much topographic information. There are some tools up here on the ribbon that allow us to sort of strip down the number of points if we feel like it's too much information. So up here on the ribbon we have Simplify Surface, and what this tool does is it specifies the minimum distance that you want between these black dots which define the topo surface. Now, when you're orbiting around and looking at this mode right now, after you've imported the points from your surveyor and your display is kind of slow and chunky, that means you've probably got more data than you need from the survey. So if you hit Simplify Surface, you can put something like 2 feet in, and that means that if Revit sees those black dots that define the topo surface, it'll try and keep them at least 2 feet apart before it has the next one. So it'll strip out a bunch of those topo surface points so that there's fewer of them. So you can see how many of them just got culled. It basically culls out a bunch of the points, removes them, and basically reduces the number of those little topo surface points in the model. So that's what that is for. So let's hit finish there and go down to the bottom here, and we'll turn on shading so we can see the dirt model that's been created. So that's how a topographic model is created.
Well, after you stripping all those points, that means that the contour getting even more rough.
Yes, that's right. So what this does is it makes the resulting surface of the model perhaps a little bit rougher. So if you have more points, it does make for a smoother model of the topography, but that doesn't mean more accurate, right? Because those are interpolated polylines, so they're not truly accurate to the undulations of the site anyway. Now, what we're going to get into next here is we're going to talk about the different kinds of tools, and I'm going to skip over page 2 of the notes, but you can go back and look at that later. What we're going to do right now is go over to page 3 and talk about the topo surface editing tools. So, when we build our site model, typically we're going to have CAD data from our site. So here you can see the red line, that is our property line. And we're going to have some CAD data that's from off the site. So typically the surveyor will provide some off-site topographic information when they provide the survey to you to use in your project. But here's the thing. Once you finish the topographic model here, folks, I want you to click on the edge of it and choose Edit. So once you've created the topographic model of your site, we're going to be able to regrade the site. So we can make some parts lower. We can create a raised area here at the building. So if we want the building to sit up a couple of feet above its surroundings, you folks will notice up here on the ribbon that there is a place point tool. So in this particular survey that we've got, this CAD file, the contour lines go all the way down to 0. So this building is right at sea level, so presumably you know, it's at a beach or it's someplace where it's going to be protected from the ocean coming in. So right now this building right here is sitting at basically Z equals 0 in terms of its height above sea level. So that would be obviously unusual. But for the purpose of this exercise, now what we can do is we can lift the grade at the building if we want to raise it up. So with the place point tool, you folks can specify the height of the point that you're adding to the topographic model. And Henry will probably have shown some of you in the intro course how to add some additional points around that initial model that you made in the intro course. And so here we're kind of going through that same process, replacing point, giving them an elevation of 2 feet, and replacing a few of them around the outside of the building. And you can see that it's regrading the model. We're adding up some height there. Can't see the CAD file anymore. Has anybody got a suggestion as to what we could do? Yes, transparency. So let's go down and set our model display to wireframe, which will allow us to see through the topography, which has now become higher than the CAD file in the background here. Now, I've added a few points at 2 feet, and so I am raising the ground. Where am I raising the ground from? Well, it started off at 0 here, and then it's coming back to the height of whatever these points are at over here at the hill. Well, what are their heights? Well, if you folks hit escape twice so that you're outside of the place point mode, you can select one of those points and you can see its height. So its height is at 0. So at the bottom of the hill, the contours come right down to sea level. So that's obviously really unusual. So what's happened is that we've made the ground higher, 2 feet here, and now it's sloping back to the hill here. So it's going from 2 feet here and then slowly sloping back to the mountainside. So what we're basically saying is raise the school up to 2 feet here, and I need to move some of these points over here because they're not quite around all of the school. So here I'm in editing the surface mode and I'm just moving these points around. So what I'm doing in effect is I am dumping dirt like everywhere around the building so that I can gently slope from here back to the hill. Chances of that happening in real life? 0. So what would really happen? Well, we'd place some points at 0, kind of out here, basically saying this is going to stay at 0 all the way around the building, and we just kind of trace our way around the building, and we are not regrading the site beyond that point. So we've got this one point in the middle here where we are raising grade, but we're not doing it anywhere else. Now, if you don't see kind of what I've got on my screen here, we'll talk about some of the reasons for that presently here. So what we've got is we've raised the ground 2 feet, roughly where the building is, and I've just put those points in every 20 or 30 feet or so, and that's about all the accuracy that you would need. And then I put another set of points whose height is 0. So you'll notice that when I click on those points after I've created them, that one's elevation is 0. These ones here, their value is 2 feet. So when you've clicked Edit Surface, and you're going to see all these tools that are in front of you, the Place Point tool allows you to add points at a value that you choose. So those ones on the inside set of points, I set the value at 2 feet, and then I click, went away all the way around the perimeter. Then for the outer points, I set my elevation to 0, and then did a second set of points all the way around the building. So you can see the contour lines there. At the building's perimeter, there's a contour line for 2 feet, and then there's a contour line for 1 foot, and then there's a contour line for 0 feet. And so what happens is we go flat from the hill till we get to here, then we go up 2 feet to the building, then we go across, and we drop back down to 0 again, and then flat over to the edge of the mountain. Nonetheless, Houston, we have a problem because no matter what I do here, I am inevitably going to regrade area that's not mine to grade, i.e. off-site. So the next tool we're going to talk about is the Split Surface tool, which will ensure that we separate our on-site topography from our off-site topography. So if you folks want to hit the green check box up at the top of the screen here to complete, that's good. So we've done our little regrading job. I can tell you, dollars to donuts, that we have done some damage in terms of regrading off-site. Now we're not going to worry about fixing that right now. Instead, we're just going to go right into the split surface tool and show you folks how it works. Make sure your view is set to wireframe so that you can see through the topography. Otherwise, you end up with this, where the topography is hiding the AutoCAD drawing, where the parts of it are higher than the AutoCAD lines, which are at Z equals 0, and of course there's some topography here that's at 2 feet. So make sure you are looking using wireframe at your site plan. So the split surface tool on the massing and site tab, here it is here. And now Revit asks, select a surface to split. So put your cursor on the edge of the Toposurface and click it. So now what you're going to do is draw the boundary that will split this Toposurface into 2 pieces. So you can either just use the draw tool and pick the AutoCAD drawing. It's a lot easier if you just use the pick tool. So there's the pick tool, bottom row, third from the left. So it's the rightmost of those tools on the bottom row. And just pick the property lines on all sides of the property, all the way around, 1, 2, 3, and 4. And if it's a nice closed set of segments, hit finish, hit the green check mark. So now what you have is 2 separate topo surfaces. You have the topography on site, and you have the topography that is off site. So if we look at this in 3D, there you folks go. So there's our on-site topography. Now here's the cool thing. If I select that on-site topography and I edit it, Revit will always maintain a meet condition all the way around the perimeter, no matter what you do. So the first order of business, if you folks are going to model the geometry of your site, is to use the split surface tool to split the topography that's been built from your surveyor's CAD data into 2 separate pieces, your on-site and your off-site topography. If you want, you could even delete the off-site topography if you wanted to. I'd suggest that you can just keep it because it's good there for reference. I mean, it's no serious damage probably to delete the off-site topo. It's just nice to have that context around the property so you can see how your building and site is going to integrate itself into its surroundings. Okay, so the next tool that we're going to look at here is merge surfaces. So on the massing and site tab, we have merge surfaces. What that would do is it would just undo a split surface. So if you use the split surface tool and you split the 2 pieces and you're like, oh crap, I don't want to split it that way, no big deal. Hit merge, pick the 2 pieces, 1 and 2, and Revit just glues them back together again so that they're one surface. Okay? So that's what split surface does. So I just Control Z undid that, and we're going to move on to the Subregion tool. Now, we probably showed you how to use the Subregion tool in the intro course, but let's go over it here. Now you folks can see that we have roads from the surveyor that we can see in the site plan. We're in wireframe right now, but in 3D with shading on, you can see it's dirt everywhere. Now if you want to change the overlying appearance of the site so it's grass instead of dirt, you can do that this way. Select one of the pieces of your topography and you'll see that there is a material setting in the properties palette. And you folks will notice that it says by category. Does anybody remember what that means. If it says by category, where is that found? Object styles. Object styles. So if we want all of our topography in the project to say be grass, which would be nice, it's BC. Okay, it's probably not grass, it's probably moss or mold or something slimy, but whatever, it's green. So if you go to the Manage tab and you go over to Object Styles, so go to the Manage tab and go to Object Styles, and go down to the Toposurface category in Object Styles. So there it is there, topography. And look at the material that's been chosen. Earth, right? That's what Alberta looks like, or Saskatchewan. But we're green here, so we can switch from earth. So put your cursor over here where it says earth, and you guys can see the little green button here. A little button on the side here. So in Object Styles, on the Manage tab, go to Object Styles, scroll on down to Topography, and change it from earth by clicking the little button on the right hand side there. And we want grass. So this is the materials dialog box, so we want grass. So in the top left, choose grass. Not here. So what we need to do is get grass from the softwares library. And down at the bottom of the screen here, there's a little arrow that allows us to search for our missing grass material from the software's own library. So grass wasn't found in the document, but at the bottom of the screen here, if your library panel isn't showing, you can make it appear. There's our grass. So if we hit the little up arrow here, it allows us to import the grass into the project. Now before, what's that?
I'm getting glass, not grass.
Oh, maybe check in the top left and make sure you use GRASS. You might have just used GL.
No, maybe the material is not being installed.
How many people here can't find grass if you type it up top? It's not showing up in the bottom. Is it showing up in the bottom for you guys? Okay, good, because sometimes IT screws up the installation and the out-of-the-box materials aren't there. So, okay, yeah. Hit grass, hit the little up arrow, it'll be there. Before you leave, hit the checkbox, use render appearance, which will make your grass appear green in shaded mode. Import grass, hit the checkbox for use render appearance, hit OK. So now our site will look like grass. It'll be green. Now you can see that we've got some paved areas that we want to show on our site. So now we're going to talk about the Subregion tool on page 3 of our notes. Let's go back to the site plan and let's put in a subregion. So on the Massing and Site tab, find the Subregion tool. So with the Subregion tool, you just start drawing some lines on the screen where you want to indicate a roadway or a planting bed or a sidewalk or a dirt or a gravel path. So we're going to use the pick tool in this case again, and let's just go around this outside perimeter of roads here and pick the arc in the corner as well. So just go all the way around the perimeter here. So that's our first step, getting those outside roads. And then we'll do the inside road, including the arcs at the corners here. And once you get to the lay-by here, where the road curves around, we're going to get that as well. We're also going to get the island in the center here. And make sure you don't miss any of the little pieces here. And so we'll keep this simple. I'm going to ignore this island in the parking lot. So I'm picking all the curves, including the parking lot here, just ignoring the island in the parking lot. So you should see roughly this on your screens. Now you'll want to make sure that you don't pick any of those lines or arcs more than once, because that'll create trouble for you. So once you've done all of this, there's 2 more lines that you guys will have to draw yourselves. And of course what they are is that this is not a valid sketch. I've got these open ends here and here. So just use the line tool from the tool palette and draw those yourself. So this is what you're going to want to see. So the pink line comes down from the parking lot here, and then you have to draw these little segments on the end of those bits that stick down. Okay, before you're done with the sketch, we want to indicate to Revit that we want this to be asphalt.
After you select all the one before, what was the step after that?
What about the which?
You select all the grade before and after you float?
You can, but you have to draw this segment here and this segment here at the bottom. You have to draw those yourself.
Like before select all this? Or?
Yeah, all of this, and I skipped this island in here. I mean, what the heck, I might as well just grab it, right? I mean, it doesn't take that much work to grab it here. And of course, anybody know that a faster way than picking each one? Anybody? Well, no, if I want to grab all these lines easily using a Revit feature, using the pick tool, does anybody remember what it's called? You guys cannot be members of my cult. Close. It's hover, tab, there's one piece missing. Anybody? Hover, tab, click, right? Hover, and then you tap the tab key once, tab. See, and all those AutoCAD lines are all selected. And then click. Hover, tab, click. So instead of going around and picking them all one by one, put your cursor over it, hover, tab, click. So once you've got all the lines around the perimeter and you've got the lay-by and the island in the lay-by, which you could get by hover, tab, click, you still have to draw these 2 lines here and here manually yourself, just with the line tool. Now, almost done here. We need to tell Revit what material we want this thing to appear as. In the properties palette, you folks need to switch the materials. It's not going to be grass, so put your cursor in here. There's the little gray button. Again, the dialog box will pull up, and you got to type in asphalt. So ASP. We don't even have asphalt paving in this file. So again, from the library at the bottom, there's our asphalt pavement, and we need to import that as well. And again, hit the checkbox so that it will appear black when it is shaded. So we imported the grass, and now we're importing the asphalt material, hitting that render appearance checkbox there on the graphics tab. And so now when we hit OK, and we hit finish, when we look at this thing in 3D, we should now see that indeed there is our pavement all around the perimeter of the building with grass in the middle, and our island, which has been left as grass.
What do you do with your lines over whatever?
You've got some issues with lines? Yeah. Andrew, do you want to help Louise with the lines there? So if you've got a few of you that need help, that's cool. I'm just going to pause the video now.